This one is also unmanned still, but this time we want this train to decelerate very quickly, and then have, once it stops, have 3 seconds to evacuate. So it's going to go like that. At the top of its path, when the train has stopped, that's it, people are coming out. So what does its position function look like as a function of time? It just looks like a straight line, right? You go, you stop, and then people evacuate, so the position is not changing. X as a function of t. Then the collision happens. The 3 seconds is the time interval spent after you stopped. So this is equal to 3. So what is our approach over here? Okay. So the final position of train A equals 44t minus a over 2t squared. Okay. Now we can come up with for an expression for how much time it takes for train A to stop. V final of train A equals 44 minus AT, and we want the V final to be 0 in this case, right? In the previous problem, we wanted the final velocity to be negative 58. We wanted it to be the same velocity as the train A, but here we set it equal to 0. A is equal to 44 over T. Substitute that into here, we get 44T minus 44. This one, A is going to be 44 over T, and then you have the 2 also, right? So I'm substituting A is equal to 44 over T. So 44 over T, then the 2 is left. Then we have here T squared. And then the T and the T cancel. So you get here X final of train A equals 44T minus T and T cancel, and then you're left with 22T, right? And then you have 44 minus 22 is 22T. Okay? So what is T? T is the time that it takes from here to here. Okay? This is, we can call it delta T. The time after you stopped and train A comes and hits you. That's the delta T, that's 3 seconds. So this T that it takes to go from here, T, the time interval for you to go from here to here, that T is this T, right? 22T. So what are we going to do now? We're going to say this. After 3 seconds, after that T, the position of train B is going to equal the same as the position of train A, right? So what's the position of train B? It's going to be 260 minus 58T, right? So this is the original distance of train B. This is the velocity. Train B, how long is the train B going to take to get to the same position that train A is? This T is going to be 3 seconds greater than this T. So we can call this T prime, right? So it's going to be 260 is equal to minus 58 T plus 3. So T prime on the graph is what? It's the sum of the two. You see, T prime. So it's the total time that train B, see, train B, the total time that train B has in motion by the time that it hits train A. So it's equal to T, this T, plus 3. Therefore, this position and this position have to equal each other. Okay, so we're going to be 260 minus 58T minus 58 times 3 is equal to the position of train A, which is 22T. Okay, so we have 260 minus 58 times 3 is 1.075 seconds. That means this train has to stop very quickly. He has to stop in 1.075 seconds, and then 3 seconds more will make that what? 4.075 seconds. The train A is going to hit train B in 4.075 seconds, right? So now if I want to know the deceleration, 1.075, I put it into here. Okay, goes over here. A is equal to 44 over 1.075. 44 divided by the answer, 40.93. That's a very, very fast deceleration. Now I'm going to add the negative. Negative 40.93 meters per second squared. So I'm just adding the negative because I had already included the negative from the beginning I got the magnitude of the acceleration, so now I know he should decelerate. That's going to be a very, very fast deceleration. So that actually is about double the acceleration of the previous case. In the previous case, you're going to stop, you're going to go backwards, and you're going to collide. Here, you're going to stop really quickly, stop, evacuate in 3 seconds, and then train B will hit you, okay? Where will train B hit you? Where will they equal? Well, you can just take this t here. The t is 1.075 seconds. Put it into here, and you'll find out where the collision is happening. So 22 times 1.075. Now you get 22 times 1.075. The collision happens at 23.65 meters, okay? So now we've seen a certain scenario where trains are decelerating and going at constant speed, but we've analyzed that question from different points of view, A, B, and C, okay? We can change it up. We can even have D, E, and F. We can have variety of cases, but as long as you draw a picture, you analyze the problem, and even analyze it graphically, you can see what's happening, set up the equations, and then set them equal to each other, and then analyze the answers that you're getting, okay? So I hope this helps you. This is a very good example of a kinematics question in one dimension. Thank you.